The second concept we'll need to understand in order to work with algebra is the concept of an expression. An expression is kind of our most basic unit in algebra. And what that is variables and numbers and arithmetic symbols put together in a way that represents a number. So the key idea with an expression is you should think an expression is something we write in algebra that represents a number. An expression might contain variables, in which case we call it a variable expression, or it might not contain any variables, in which case we call it a numeric expression or an arithmetic expression. So 3x minus 1, this is a variable expression because it contains one variable, specifically x. On the other hand, negative 2 to the third power plus 11, that's a numeric expression because it does not contain any variables. And it's important that we distinguish between these because if we have a numeric expression, we can just take that and punch that into the calculator and get it to spit out a number. On the other hand, if we have a variable expression, we can't do that. There are some manipulations we can do with variable expressions, and if we know what number the variables represent, we can plug those in, and then we can get a number. But if we take a variable expression and we just punch it in on the calculator is going to do something unpredictable. It's going to spit out a number, but chances are that number is going to be nonsense. Okay, what can we do with expressions? Well, if our variables represent something in the real world, then expressions with those variables also represent something in the real world. So we're going to work with a simple example of what a variable might represent that's kind of easy to move around. And just think about what some expressions mean. So we're going to say, let x represent the number of cookies in a package. So if we have 3x, remember writing a number and a variable next to each other means multiply. So 3x means 3 copies of x. 1, 2, 3. 3x represents the number of cookies in 3 packages. Here's another expression that's a little bit more complicated. Here we have 2x plus 5. So the 2x part, that's multiplying. So that'll be 2 packages. And then the 5, right? Notice this 5 is not multiplied by x. So that's not 5 packages of cookies. That's just going to be 5 individual cookies. So 2x plus 5 represents the number of cookies in 2 packages plus 5 extra cookies. Now notice, we don't actually know which is bigger, the 2x part or the 5 part, because we don't know how many cookies there are in a package. The packages might be like little 2-packs, in which case 5 cookies is more than what we get in 2 packages. On the other hand, the packages might be like the giant industrial size box of Oreos, in which case 2 packages is much more than 5 cookies. But we can't make a comparison between 2x and 5 since we don't know how much x represents. Here's our next expression. This looks like a fraction, x thirds, but what we're usually thinking of when we see a fraction bar in algebra is division. So we're thinking of this as meaning x divided by 3. In algebra, we very rarely write division with a division sign. We write it with the fraction bar. So what this means is, so we have a package of cookies, and we split it into 3 equal parts. So this represents the number of cookies in each part if we split the package into 3 equal parts. Now, it makes a less pretty picture, so I didn't draw it. There's another way of thinking of x divided by 3. Another way of thinking of x divided by 3 is, if we divide the package into groups of 3, how many groups do we get? That is, if we give everybody 3 cookies, how many people can we give cookies to? We can also go the other way. We can create expressions to model things in the real world. So for example, if we have 4 packages of cookies and then 3 cookies are removed, right? So here I've got 4 packages of cookies and then 3 cookies are removed. The way I'm going to draw removing cookies is by putting dots inside the boxes to represent like empty spaces or something. So we have 4 packages of cookies, 3 cookies are removed. That'll be 4x. And then we take away 3. 4x minus 3 is an expression that tells us that number of cookies. And this way of thinking, what does my variable represent? How can I translate that into an expression? Is going to be very useful to us as we move on to build models describing real-world situations using algebra. When we have a complicated expression, we may want to write a simpler equivalent expression. This process is called simplifying. So if we just want a simpler expression than a given expression, we can just say 1, because 1 is a really simple expression. We don't want just any old simpler expression. We want a simpler expression that means the same thing. So we say that 2 expressions are equivalent if they have the same value, no matter what number the variable represents. When we simplify an expression, we want to write the simplest possible expression that is equivalent to the one that we started with. So just to spend some time thinking about what it means to simplify an expression, I claim that the expressions 2x plus 3x and 5x are equivalent. And we're going to confirm that by seeing what number these expressions represent for various values of x. If x represents 0, our expression becomes 2 times 0 plus 3 times 0. And now we need to think about order of operations. We remember that multiplication always has to happen before addition. So we'll multiply 2 times 0 is 0. And then we'll multiply 3 times 0 is also 0. And finally, we'll add 0 plus 0 is 0. So if x represents the number 0, our first expression evaluates to 0. Our second expression is just 5 times 0, which is just 0. Okay, let's see one more of these by hand, and then we'll notice that we can also do this on the calculator. So if x represents the number 5, then in our first expression we have 2 times 5 plus 3 times 5. Again, we'll evaluate the multiplication first, then the addition. So we'll multiply 2 times 5 is 10. 3 times 5 is 15. And finally, we'll add 10 plus 15 is 25. For the second expression, we just need to take 5 times 5, and that equals 25. Okay, if x represents the number -3, Then we'll have 2 times negative 3 plus 3 times negative 3 for the first expression. And we'll have 5 times negative 3 for the second. And the good news is we don't actually need to go through step by step to evaluate these because our calculator knows the order of operations. So we can enter that first expression on the calculator as 2 parentheses negative 3 plus 3 parentheses negative 3. And notice I put my negative number in parentheses. That's to make it clear that I'm talking about the number negative 3 and not subtracting 3. And when I have a number in parentheses, it's not necessary to put in the times sign. Just like writing a number next to a variable means multiply, writing a number next to parentheses also means multiply. So 2 times negative 3 plus 3 times negative 3, according to the calculator, that comes out to negative 15. For the second expression, we'll enter 5 times negative 3, which by this point it should not surprise us, also comes out to negative 15. One more of these. If x represents the number 12, then our first expression is 2 times 12 plus 3 times 12. Since this is a positive number, I don't need to put it in parentheses. But of course, then when I enter this on the calculator, I need to use the times sign. So 2 times 12 plus 3 times 12. I get 60. And for the second expression, I'll have 5 times 12. Which is also 60. And so we see that at least for these 4 values of x, each of these expressions works out to give us the same final value. Now that doesn't technically prove that these expressions are equivalent. It doesn't prove that this is going to work for every number, because there are a lot more than 4 numbers. However, what it does show is that it works for 4 numbers. And they were 4 numbers that we picked kind of at random. So we'd have to be really unlucky if these expressions were not equivalent, but they gave us the same value 4 times. And in fact, it seems to make sense to think of these 2 expressions being equivalent, right? If we're thinking in terms of the cookies again, right? 2x, that's 2 boxes of cookies, plus 3x, that's 3 boxes of cookies. We'd expect that to give us 1, 2, 3, 4, 5 boxes of cookies. So it seems to make sense that these will in fact be equivalent. Now, also notice that in all of those calculations, 5x was easier to work with, right? Figuring out what 5 times 12 was easier than figuring out 2 times 12 plus 3 times 12, and so on. Because it's easier to write and it's easier to evaluate, we say that 5x is simpler than 2x plus 3x. If we rewrite 2x plus 3x as 5x instead, then we say that we have simplified that expression.